The engineers who get replaced in the next 5 years, they'll be replaced by engineers who know 4 specific skills. If you do not build these skills now, the gap between you and the people who are learning these skills is going to grow tremendously, faster than any technical skills that you've seen in the past. And the reason they matter more than anything else right now is because they're skills that you use to orchestrate AI and communicate with a team properly. But it's not clear what it means to orchestrate AI still. The key in proper AI orchestration does rely on these 4 skills. And I've focused on these 4 skills and have seen a huge shift in my ability to produce output that is meaningful to a company. The first C being communication is your ability to extract what actually matters from human situations and maybe messy human situations and translate that into constraints that a system or a model can actually work with. It also has to do with how you translate ideas in your mind into sentences so other people can actually understand the points of view that you have from what you've seen. The team needs to operate on the same level of understanding a concept without you being the one who is the bottleneck in that system. Understanding really good context and understanding how to pack that context into an efficient space is a key skill. I believe people who do not understand this skill will get fired for poor communication, not just with other people being the bottleneck in a team, but being too vague and maybe not even understanding what is going on in the team and understanding how to communicate properly with a model to achieve the proper end result. The second C then is comprehension. At some point, IQ is a real factor here. Some people just do not have a higher IQ, and that makes this element more difficult in reality. But how you dive into a complex system that you've never seen before and how you understand it, and how fast you're able to understand that system and understand why the problems the team is having are those problems they're having, and being able to connect that to the larger goal. This is a real problem, even with super intelligent large language models. If your team inherits a system, let's say, that has a service and it's timing out under load, and you point an agent at it, and the agent refactors something. Let's say it refactors a function that it thought was really slow, but the actual problem may have been an n+1 query buried 3 layers deep in a dependency that you never thought to examine because maybe you never comprehended the system to begin with, not beyond the surface level anyways. There's sub-level systems at different layers that matter for engineers to understand, even if AI is super intelligent. Because in order to leverage an LLM that is highly intelligent, you have to have highly intelligent humans to be able to verify that it's doing what we want it to do. This is another skill that if someone does not have this capability, obviously still somebody could get fired and the timeouts continue and that person burns through different tickets in the sprint, and then the issues continue to arise later. But the engineer who spent an hour reading up on the detailed issue, understanding how dependency chains actually work before prompting the agent, or someone who naturally understands a larger picture of the system and the details involved in the problem at hand, can maximize agents to leverage them and be sure the fix is the proper fix and that it's going to work for a reason that is actually understood. So this brings us to V, the first V of the CCVV, verification. That's the whole point here, is how do you know whether the thing you built actually does what it's supposed to do? Comprehension overlaps on this. It's also about the conditions that matter. What conditions matter for the system at play? An agent generates a caching layer and passes every test, let's say. But if you never verified behavior under the cache invalidation during the concurrent writes, 2 weeks later, users can start seeing stale data. That costs a real customer from a bad decision based on the wrong numbers. The tests might pass, but the system can still be broken. The engineer has to understand the tests, understand what to verify within those tests, and understand what's beyond that happy path before something gets deployed. So the person that just trusts green continuous integration probably won't be keeping up on this skill. To be able to verify using comprehension whether or not a system is actually doing what it says or what it tells you it's doing, the ability to debug, log, trace things at a detailed level, that's still necessary for humans to verify. So all of this comes back around to the vision, which is the second V, and the vision is the why. Why are you building anything at all in the first place? If you don't understand this as a human, don't get into development. But there are layers to this. Let's say you prompt an agent and you ship something in a day. It looks great, but if nobody is asking whether this feature actually solves the problem the business needed to begin with, 3 months later, if somebody understood both the system and the end vision, and a lot of work can be saved. Sometimes a team doesn't understand the vision at hand. Developers don't even ask. Some developers don't even think to ask, how does this pertain to the larger vision? In doing that, tons of work could be all for nothing. Or if a team fully understands that, they could actually come up with better solutions than would have otherwise been thought of by leadership. If the team is building an elaborate notification system that one person thought might be cool to have, and later they realize that doesn't align with the vision, it doesn't align with what matters, that's a lot of wasted time, it's a lot of wasted effort. Some of these single concepts are some of the biggest issues in business, where it makes or breaks whether or not the business is going to be relevant in the next year. It can affect other features, it can cause psychological issues in both the development team and leadership, where they're fighting each other on what to do, why to do it. And this all comes back to communication. All these 4 skills overlap. So where do I see all of this going? And I think this is the part that most engineers just have not caught up on yet, which is that the future of software engineering looks more like software architecture, unique forms of communication and management, or orchestration, whatever you want to call it. So AI orchestration, systems thinking to achieve an end goal, or understanding an end state that's correct, being able to communicate with people on why that's the correct end state that's wanted and desired, acting almost as a business consultant with the business as an engineer to make sure that the business is responsible in understanding why it's doing what it's doing. So at some level, it's also being able to comprehend and understand business practice at some level, and being able to maintain this ongoing adaptability of making sure a system is safe when requirements change, that it continues to behave the way that the business needs it to behave and changes in a direction that's most optimal for the business. Software architecture includes this ability to look at these trade-offs for different structures within a system. You are not typing implementation anymore. Just like, if you have not gotten past this, I think you're just going to be surprised for what's coming. If you haven't seen what everyone else is doing in the industry, we need to be shaping structure, verifying behavior, and just making sure the whole system works properly, using the leverage of proper communication with agents and humans alike. But there's one more piece I think developers are really underestimating within the business operations side. And this may depend on the size of the company to some degree, but engineers who understand financial and operational reality of what they're building fundamentally, that matters and will determine on which architectural decisions you decide to make. Engineers, I believe, in the future who are valued most will know which trade-offs will cost money, will be able to tie finance and business operations into the architecture directly. Hopefully, better systems are built to be able to do that and assist engineers in knowing which decisions are going to be impacted most in doing that. Which boundaries protect revenue? Which structural problems are currently draining the engineering budget? What is time being put into? Whether developers like it or not, this literacy is becoming part of the job. It's because the systems we're building, they're not in a vacuum. It's all inside systems, businesses that need the systems to work economically. In the next video, I really want to get concrete about this particular idea, the core software architecture metrics that are directly tied to financial impact. How do we actually detect them? How do we, in a real code base, how do we best leverage AI to resolve these structural problems that we can reveal? So that's where it stops being theory and really starts becoming something that you can actually leverage this week. And in all practicality, that's going to be my next video, so stick around. Thanks for watching.